Okay, so in this presentation, I'm going to outline how we can use zk-SNARKs in terms of creating zero-knowledge proofs. So one of the most advanced zero-knowledge proofs is zk-SNARKs. With zk-SNARKs, what we're able to do is that we're able to prove the knowledge of something without actually revealing what that knowledge is. So a typical application of this is where we have something like a mathematical formula. So in this case, we have ax squared plus bx plus c is equal to y. Is it possible for us to show that for a certain value of x, we can compute y? And then for us to be able to create a zero-knowledge proof to not reveal the x and the y value, but to show that we have actually calculated it correctly. In this way, the verifier, typically known as Victor, will be able to verify that Peggy, the prover, has been able to solve the equation in this case. So we start with a basic definition, and in this case we define the fields that are actually involved in the zero-knowledge proof. In this case, we're using a, b, and c. Those are the values of ax squared plus bx plus c. And then we have a private field of x and a private field of y. In this case, what we'll do is that we'll be able to create a zero-knowledge proof to be able to prove that we know the values of x and y, and to create that proof. So that if the value that we pass in here is equal to the value we compute, then we know that the zero-knowledge proof is correct. Okay, so with we install the plugin, and then we can actually compile our little program that we have here. The next is that we can try a little compute example. So if I say 3x squared plus 2x plus 1, and if I go for a value of 1, then we will have 3 plus 2 plus 1 for our value, which gives us a value of 6. Okay, we'll try that, and that works. If we came up with 7, or we can see we get a false here, but if we get the answer correct, we'll generate a true. Next, what we'll do is that we'll generate the proof. For zk-SNARKs, we need to generate a verification key and also a proving key. So all of this is done off-chain and for the setup of our zk-SNARKs. So when we run this, this will create our keys that we require to be able to protect our smart contract. Okay, so those are set up, and then we'll generate our proof. Okay, it just takes a little minute, and we have our proof here for 3, 2, 1, and 1. And for these values, this is the proof that we will generate. Okay, if we want, we can copy this to be able to prove our smart contract. Okay, so then after this, what we'll do is we'll export, and this will create a Solidity contract for us. Here is our contract here, and the contract has this part which is exposed that we can input our 4 input values, and then we'll get a result back to verify the proof or not. Okay, so from here we'll just copy that. We can use that later. Okay, so now we'll take our Solidity file and we will compile it into the code that's required for our smart contract to run on the Ethereum blockchain. Okay, we take a quick note of the compiler that we're using. So it's important to get that because we'll need that later. We're building it to Solidity and everything should be fine there. So it just takes a little minute to compile it. And we can see that we have two contracts here, verifier and the pairing one. Okay, so we should now be able to publish that to the Ethereum blockchain. So just let me find out where we are. Okay, so now what we'll do is that we'll hopefully look to publish this onto Ethereum. Okay, so I'm going to upload the smart contracts into a test network, this one here, and I've linked my account there. And what I'll do is I'll upload or deploy the smart contract to Ethereum, the Ethereum test network. Okay, so it just takes a little minute and we'll just upload that there. Just takes a little minute for the contract to be deployed. Okay, so we've now deployed the contract and we'll just have a little look. There's the details of it, shows me how much gas that I've used, but we'll go and have a look at it on the Ethereum test network now. Okay, so what we can see here is the that's my account there, and this is the contract that's been created there. So the contract hasn't actually been deployed yet. We need to be able to validate the contract. Okay, so there's some of the details around it. So we'll just click on here, and there's the bytecode that we're using. You can have a look at the opcode in there. That's what our Ethereum code looks like. But we'll just go back there, and what we'll do is we'll now verify and publish it. Okay, so this is the address for it. We'll define the compiler, and then the compiler version I think is this one that we used, and I'll just put no license on it there. Okay, so that's just defining the basics of our smart contract. Now what we need to do is that we need to go back and find our Solidity code, and then we paste it here to be able to verify the contract. If I can remember what a fire hydrant looks like. There we go. Okay, so we'll just verify that. Should just take less than 30 seconds to be able to verify the code, hopefully. So this is the address that the contract is at, and that's the contract there, the Solidity contract, and obviously it's compiled into bytecode to be able to run off the Ethereum blockchain. So it's just taking a little minute while it does this. As it says, it takes up to 45 seconds, and that's it. Okay, so that's what our code looks like. There's the abstraction of the interface for the data, but that's the code that's going to be running on there. Okay, so what we'll do is that we'll now test it to make sure it's working okay. So here's a contract, so you can actually see each contract, you can actually look at the code that's developed for it, so nothing secret there. So we'll just have a look here, and we can see we've exposed one read contract here. So in here, what we want to do is to feed in some parameters into our zk-SNARKs. Okay, so what we've got is that we've got the parameters that we feed into our zero knowledge proof method. So I've copied and pasted the parameters from before. So this was our proof, We'll just paste that in there. And then we want to add in our values, which I think were 3, 1, 4, and 1. 1, 4, and 1. Make a query, and we can see that is false. Okay, let's check. 3, 1, 4, 1. And we'll go back to our original one, and then we'll just have a look at our proof again, just to see if I've obviously pasted in the wrong values here. So where are we? That's there. Okay, so let me generate the proof again. So the 3, 2, 1, 3, 2, 1, 1, 6. 3, 2, 1, 1, 6, and I'll generate the proof again. Okay, let me copy that and just move that there. Okay, so here's our proof. And the values that we have are 3, 2, 1, 1, 3, 2, 1, 1, and we get a true for that. Okay, so you can see for the input parameters and for this proof, that's correct. But then if I try the other values, then we will get an incorrect value. Okay, so in this way we can actually prove something without actually revealing the values that that we have for y. So in here we've computed the value of y and created a zero knowledge proof for it. And then we've given the values of a, b, c, and x. Okay, thank you.